Hi friends, today we see about pressure relief valve. Pressure relief valves. Pressure relief valves protect the system from excessive fluid pressure over and above the design pressure limit. Normally located in between pump and actuator, its types are direct acting or simple pressure relief, pilot operated or compound pressure relief. First one, direct acting or simple pressure relief valve. Direct acting pressure relief valve has a ball or poppet or a sliding spool against a spring. It has one inlet port which is normally closed by a spring force. When the inlet pressure overcomes the spring force, the valve opens and the fluid flows back to the sump. Thus, the pressure relief valve protects the other element from excessive pressure. Second one is compound or pilot operated pressure relief valve. The fluid passes from the inlet port through the orifice to a control chamber which acts on the main poppet to add to the spring force. When the system pressure exceeds the setting pressure of main poppet, the poppet is pushed from the seat towards left. This action forces the pressurized fluid on the left to escape through the centrally drilled drain hole, which limits the pressure on the control chamber. Due to this, the fluid cannot enter control chamber or the fluid leaves through the drain hole. Because of this, the pressure on the right exceeds the left and the main poppet moves to the left. Thus, it permits the fluid flow directly to the reservoir from the inlet port. Then, pressure reducing valve. A pressure reducing or regulating valve is used to supply a prescribed reduced pressure in a circuit to maintain a constant pressure. Its types are direct acting pressure reducing valve, pilot operated pressure reducing valve. First one, it shows the diagram, the direct acting pressure reducing valve. It has a spring loaded spool to control outlet pressure when the main supply pressure is below the valve setting pressure. Fluid will flow freely from inlet to outlet. When the supply pressure exceeds the valve setting pressure, the spool moves to left and partially blocks the outlet. There is only enough flow. The, pro- the passes the outlet to maintain the pressure. Note, the pilot operated pressure reducing valve works the same principle as compound pressure relief valve acting. Then sequence valve. It's used to control the fluid flow to ensure several operations in a particular order of priority in the system. When the system inlet pressure is within the present valve pressure, the valve allows free fluid flow. When the system pressure exceeds the preset value, the spool moves up and down to operate the secondary phase. Flow control valves. It's used to regulate the rate of fluid flow. Its types are non-pressure compensated fluid flow valve. It have categorized into globe valve, needle valve, then pressure compensated flow valve. The diagram shows these kind of valves. Non-pressure compensated flow control valve. This type of fluid flow control valves are used where pressure varies considerably. Working principle of this valve is that fluid flow, the orifice will be constant if the pressure drops remains constant. Globe valve. The flow rate can be changed by means of disc, plug or ball which nest against a seat. Disc type globe valve, also called butterfly valve, consists of rotating disc inside the pipe. Its angle of rotation determines the flow rate. Plug type globe valve uses tapered plug to control the flow rate by varying the vertical plug position. Ball type globe bob has a ball with a through hole which is rotating inside a machined seat. Needle valve. The needle valve has a pointed stem which can be adjusted to control the flow rate. The pressure compensated flow control valve. It consists of two ports. Throttle valves are pressure compensating pool. The throttle valve has an orifice whose area can be adjusted by knob seating. Servo and proportional valves. Servo valve. A servo valve is a DC valve having infinite number of valve positions. Usually, servo valves are coupled with feedback device. It can control direction, flow, velocity, position, etc. Types of servo valve: hydromechanical servo valve, electro-hydraulic servo valve. The electro-hydraulic servo valve categorized into single-stage servo valve, two-stage servo valve, jet pipe servo valve, flapper jet servo valve. Hydromechanical servo valve. A small force applied on the main spool shifts it towards the right, which allows oil to enter through the port P1 from inlet. Oil from inlet port enters P1 and causes the cylinder to react towards the right, as shown in figure. Thus, the given input motion has produced a specific output motion, and the output motion is feedback to modify the input through the feedback line. The lab conditions: closed center servo valve. Lands are large, than ports. Open center servo valve. Lands are narrower than port. Hydromechanical servo valve in steering applications. Input force in a turning of steering wheel. The steering wheel movement permits the sliding sleeve to allow oil from port to the steering cylinder, which in turn moves wheel through steering linkage. Since the valve spool is attached to the linkage, it also moves along with linkage. When the valve spool has moved far enough, it cuts off the flow to the cylinder by blocking the port. Thus, the motion of cylinder is stopped. Thus, the given input force, steering wheel movement, has produced a specific output motion, wheel movement, and the output motion is to feedback to modify the line. Electro-hydraulic servo valve. The electro-hydraulic servo valve operates due to an electric signal to its torque motor, which positions the spool valve or DC valve. In simple, the electrical signal is used as input signal to control the hydraulic output. Single-stage electro-hydraulic servo valve. An electric signal is passed through the coils of a torque motor. The torque motor produces an armature deflection depends upon the input current. Since the armature of the torque motor is directly connected to the valve spool, the spool also shifts by distance proportional to the change in current. Two-stage electro-hydraulic servo valve. It consists of a main stage and a pilot stage. The input signal produces an armature deflection proportional to the input current. The armature deflection is mechanically transmitted to the pilot spool by means of stuff wire. If suppose the electrical signal causes the pilot spool to shift towards left, the land X allows oil flow to end B of the main spool, which causes the main spool to move towards right, which in turn pushes the sleeve towards right. The main valve stops moving when the hole in pilot sleeve exactly aligned with the land on the spool. A feedback links connected to the main spool. jet pipe, electro-hydraulic servo valve.